We will now see a demonstration of the DAC in which an edge node device has generated a new data item with sensor readings like this, and it wishes to encrypt them under ABE using the ABE client that is running on the device, on the edge node. So the first thing would be to obtain public key from the ABE keys issuing authority that is running on the cloud. This should be done only once. So the edge node sends request for the ABE keys issuing authority running on the cloud and receives back a public key. And then using this public key, the edge node encrypts the sensor readings under a specified ABE access policy that specifies who shall be able to read the data and decrypt the data. So we have here an example of ABE access policy by which entity will be able to decrypt the data if it is of role analyzer and with a purpose of security anomaly detection, or purpose data visualization and of domain of sensor readings, or any admin or supervisor from the IBM organization. So the edge node then can send this data, including the sensor readings and the ABE access policy and the public key, to the endpoint exposed by the ABE client and receive back the ciphertext. So let's run this example. We can see that the public key is being returned from the ABE keys issuing authority, and then encrypting this new data item, the sensor readings under this ABE access policy, and being receiving the ciphertext from the ABE client. Now the next thing would be the edge node to send transaction to the blockchain ledger in order to document this event of generating data item and encrypting it. So the edge node takes these sensor readings and the ABE access policy and produces a hash of the sensor readings and sends to the blockchain ledger the hash of the data item and the ABE access policy by which the data was encrypted. And together with its certificate and key, it inserts new record into the blockchain ledger, into the Hyperledger Fabric ledger, sending request to the Hyperledger Fabric client endpoint that is exposed from within the device. And then the edge node can, and of course it's optional, can query the ledger and make sure that the transaction has indeed been committed into the ledger using a second endpoint exposed by the Hyperledger Fabric client. So let's run this example as well and see the results. So you can see new record being added to the ledger with this hash of the content of the data item and this ABE access policy. And the Hyperledger Fabric client sends a successful request, and then we can query the ledger and see that indeed this record was committed into the ledger with the creator of the record and this type of record, which is sensor readings, and the ABE access policy and hash documented in the ledger. So the next thing would be an edge node to send the encrypted data to the field gateway, and then a process from within the field gateway, for example, analytics, can consume the data, can take the data and decrypt it and use it for its analytics. So in order to do this, the process on the field gateway needs to obtain both public key and secret key from the ABE keys issuing authority that is running on the cloud. The secret key encodes the attributes of this entity that wishes to decrypt the data. And then after obtaining secret key and public key, which again is only done once, the process can go ahead and decrypt the data, taking the ciphertext that was obtained from the edge node, and together with the secret and public key, send request to an ABE client that is running on the field gateway and receive back a plain text version of the data item. So let's see this working. All right, so we can see the public key and the secret key that were obtained from the IBE acquisition authority, and then approaching the IBE client in order to decrypt the ciphertext, resulting with plain text that is very similar to the sensor readings that we started with in the edge node. Now, the last thing would be for this data to be shared with the cloud and stored on the cloud storage service. And doing this, we would like to document the location in which the data is stored on the storage service. It can be a URL, it could be the name of a unique key in the database. And here we have an example of a process on the cloud that adds this pointer to where the data is stored into the blockchain ledger. So we have this example of a dummy pointer on the cloud, in this case a URL, and the ID of the data item on which we reference. And here we can see the process sending request to the Hyperledger Fabric client that is running on the cloud to add the pointer to a sensor data item. And similar to what we saw on the edge node, he can then send the second request to the Hyperledger Fabric client to query the ledger and see that the transaction was successful. So let's see this example on action. The transaction is processed pretty quickly, 1 to 2 seconds for a transaction to be committed into the ledger. And then we receive 200 status codes from the Hyperledger Fabric client for adding this pointer. And following the successful request, we can see the record inserted and committed into the Hyperledger Fabric ledger with this pointer pointing to where the data is stored on the cloud.